You're sitting on your couch, lights dim, phone in hand, completely relaxed. Nothing around you can hurt you. Your front door is locked. Your body is doing absolutely nothing dangerous. And then, on the screen in front of you, something jumps out from behind a door in a horror movie, and your entire body reacts like a bomb went off next to your head. Your shoulders snap up, your hands fly toward your face. Your heart slams against your ribs so hard you can feel it in your throat. For a full half second, you are not a person watching a movie. You are prey. And here's the part that should bother you more than it does. Nothing actually happened. No creature leapt at you. No branch snapped behind your head. A collection of pixels rearranged themselves in a specific pattern on a flat rectangle, and your nervous system responded as if your life were genuinely on the line, not startled in some vague, casual sense. We're talking full sympathetic nervous system activation, adrenaline dump, pupils dilating, blood rerouting away from your digestive system and into your limbs. Your body preparing in that instant to either fight something or run from it based on nothing but light and motion on a screen. Think about how strange that actually is. You know intellectually, with total certainty, that nothing in that room can hurt you. You paid for the streaming subscription. You picked the movie. You are, in every rational sense, in complete control of the situation. And your body does not care. Your body does not consult your rational brain before it reacts. It just goes. Every single time. Even on the 5th rewatch, when you already know exactly when the jump scare is coming, some part of you still flinches. Why does a system this old, this deeply wired, still get fooled by something this fake? Let's start with the obvious explanation, because it's the one that's usually wrong. Most people assume this is just about fear. You see something scary, you get scared, end of story. But that's not actually what's happening. And here's how we know. The flinch happens before fear does. Before you consciously register what you saw, before any emotional response has time to form, your body has already moved. That gap between sudden visual stimulus and physical reaction is measured in milliseconds, somewhere around 100 to 200 of them, which is faster than your conscious brain can even finish processing what it just looked at. You are reacting to something before you know what it is. That's not fear, that's something much older than fear. What you're actually looking at is a leftover survival mechanism called the startle reflex. And it did not evolve for horror movies. It evolved for a world where sudden movement in your peripheral vision meant one of exactly two things. Something is about to eat you, or something you're about to eat is trying to escape. There was no third option. There was no harmless, flickering light category in the ancestral environment. If something moved fast and unexpectedly, it mattered. And it mattered immediately because the difference between reacting in 150 milliseconds and reacting in 400 milliseconds could be the difference between surviving an ambush and becoming someone's dinner. So evolution did something clever and honestly a little terrifying when you think about it directly. It built a shortcut. A part of your brain called the amygdala, sitting deep in the middle of your skull, doesn't wait for the slow, careful, detail-oriented visual processing that happens in your cortex. It has its own direct, low-resolution feed straight from your eyes, sometimes called the low road, and that feed skips almost all the analysis. It doesn't check what the shape is. It doesn't check what colour it is. It barely checks anything at all. It just asks one question. Is this sudden? Is this fast? Is this coming toward me? If yes, react first. Figure out the details later. Your amygdala would rather you flinch at a plastic bag blowing across a parking lot 1,000 times than miss the one time it's actually a predator. This is why you can know with total certainty that the thing jumping out of the closet in a movie is an actor in makeup, lit by a crew, filmed months ago, and your body still reacts like it's happening to you right now, in real time. With real stakes. Your amygdala isn't watching the movie with the rest of your brain. It's not tracking plot or character motivation or the fact that you're sitting in your living room. It's just watching for sudden motion. And a screen full of rapidly changing light is, from its perspective, functionally identical to something moving through actual physical space in front of you. Your brain isn't even that picky about what counts as real. There's a concept in psychology called ecological validity. The idea that your nervous system evolved to respond to certain patterns of stimulation, and it largely doesn't care what's producing that stimulation. Real motion and simulated motion can trigger nearly identical responses because, as far as your visual system is concerned, motion is motion. Your eyes don't have a built-in "this is fiction" filter. That filter, the part of you that knows you're watching a movie, lives up in your prefrontal cortex, the slow, deliberate, conscious part of your brain. And the prefrontal cortex is simply too slow to get there first. By the time it catches up and says, wait, this isn't real, your shoulders have already jumped and your heart rate has already spiked. There's an entire field of media psychology built around exploiting exactly this gap. And horror directors have understood it instinctively for decades, long before anyone had a name for the amygdala's low road. The jump scare formula barely changes from movie to movie because it doesn't need to. Quiet, 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 sudden loud noise paired with sudden fast motion. That's it. That's the whole trick. It's not clever writing. It's not a twist you didn't see coming. It's a direct exploit of a 200,000-year-old reflex. And it works on basically everyone, every time, regardless of how many horror movies you've watched or how much you insist beforehand that this one won't get you. But here's what makes this even stranger, and it's the part almost nobody talks about. This reflex doesn't just fire for horror movies, it fires constantly in situations that have nothing to do with entertainment. Someone claps unexpectedly behind you in a quiet office, and your whole body jolts before you've even turned around. A notification pops up on your screen with a burst of motion and sound, and your shoulders twitch. A bird flies low and fast past a window while you're walking, and you duck slightly before you've consciously registered it was just a bird. None of these things are threats. Not one of them has ever actually hurt you. And your body treats every single one exactly the same way it would treat a predator breaking cover in the grass. This is because the startle reflex isn't actually evaluating danger. That's the part that trips people up. It feels like your body is assessing risk and deciding this is dangerous, react. But that's backwards. The reflex fires first and the danger assessment happens after, if it happens at all. Speed and suddenness alone are enough to trigger it. Your nervous system essentially runs on a policy of react now, apologize never. Because in the environment this system evolved in, the cost of a false alarm was basically nothing. Just a wasted half-second of tension, while the cost of a missed real threat was your entire genetic lineage ending on the spot. When the two outcomes are that lopsided, evolution doesn't build a careful, deliberate detector. It builds a trigger-happy one. And it hands that trigger to the fastest, most automatic part of your brain instead of the slowest, most thoughtful one. This reflex isn't uniquely human. Nearly every animal with a nervous system complex enough to process sudden stimuli has some version of it. Cats leap sideways at unexpected noises. Birds scatter from stillness into flight in a fraction of a second at the faintest sudden movement. Even fish, with brains a tiny fraction the size of ours, show measurable startle responses to sudden changes in light or vibration in the water around them. This tells you something important. This isn't a quirky human bug. This is one of the oldest, most conserved survival mechanisms in the entire animal kingdom, refined and preserved across hundreds of millions of years of evolution because it flat out works. Any creature that hesitated to evaluate sudden movement calmly and rationally before reacting simply didn't survive long enough to pass that hesitation on. And that brings us to the genuinely uncomfortable question sitting underneath all of this. If this reflex is this old, this deep and this automatic, what does it mean that we now spend hours a day sitting in front of screens specifically engineered to trigger it on purpose for entertainment? Every jump scare you willingly watch is your nervous system running a full, genuine threat response, adrenaline, cortisol, elevated heart rate for something that was never remotely dangerous. Multiply that across millions of people watching the same movie on the same weekend, and you've got an entire species voluntarily triggering its own ancient predator detection system over and over for fun, because the aftermath, the shaky laugh, the flood of relief once your prefrontal cortex finally catches up and confirms you're safe, feels genuinely good. That crash of relief after a false alarm is its own kind of reward, which might be the real reason horror as a genre exists in the first place. We're not watching to feel scared. We're watching to feel our own ancient alarm system fire, and then get to experience, again and again, the relief of surviving something that was never actually going to kill us. So the next time something jumps out at you on a screen and your whole body reacts before your brain even catches up, understand what you just witnessed. That wasn't weakness. That wasn't you being too jumpy or overreacting to something fake. That was a 200,000-year-old survival system forged by an environment where a half-second delay could end your bloodline, doing exactly the job it was built to do, on a target it was never designed to recognize as harmless. Your amygdala isn't broken, it's not confused, it's just doing what it has always done, reacting to sudden movement first and asking questions later, because for almost the entire history of creatures like us, that split-second head start was the only thing standing between staying alive and becoming someone else's dinner. The screen is new, the movie is new, the couch, the streaming subscription, the surround sound, all of it is new. But the flinch, that flinch is ancient and it is not going anywhere anytime soon.